So yeah, the topic today is optimizing machine utilization. And Balluff is a quite new company in Malaysia, and therefore I would also introduce my company with a couple of words in the beginning. So, okay, Balluff has globally more than 3,600 employees. So we are a quite medium-sized company with headquarters in Germany, and we basically provide automation solutions. We have more than 37,000 different sensors, identification and networking devices, and we also have 37 subsidiaries all around the world. The newest, most new subsidiary is actually here in Malaysia. Last year, we incorporated Balluff Automation Malaysia Sendirian Berhad. So you can see here on the right side a picture of our KL team and of our office. We are based in Puchong in Selangor, and here's our head office as well as our warehouse. Yeah, you can see we are just in September last year, we just incorporated our office. Before that, we actually were active from Singapore. So we have one very important sales office in Penang, and we also serve the Melaka market as well as Johor, and we actually plan a new sales office in Johor within the next 1 or 2 years. So okay, when I was invited to this webinar with the title Optimizing Machine Utilization, I was wondering, okay, which of our 37,000 products could we actually introduce, and what is the topics that the manufacturing companies and end users in the current times, what might be their challenges, what might be the topics most interesting for them. So I came up with 3 topics that I want to enhance today. One is the machine downtime. Of course, all of us are trying to avoid the picture on the left out of order, but we are trying to use the machines as much and as often as possible. Second topic is machine monitoring. So, of course, Industry 4.0 is a big topic, and many people dream of having a dashboard where they can monitor their machines 24/7 from their smartphone or from any kind of device. So I'm gonna speak about this topic quickly. And finally, also the machine flexibility can help to make machines more utilizable and to increase the usage of machines overall. Okay, so yeah, when I was thinking about our 37,000 products, which one should we focus on? The question was, the answer was actually quite easy, because there's one technology called IO-Link, and this is one of the most important enabling technologies in this century, I would almost say. And so therefore I would focus my presentation on the topic of IO-Link. My agenda would be to quickly introduce IO-Link. What exactly is it? And then quickly speak about the 3 topics I just mentioned. How can we decrease machine downtime? How can we monitor a machine? And here we also have a quick live demonstration of our sensors. And finally, how can we make machines more flexible? Okay, so what exactly is IO-Link? One of the easy definitions is IO-Link is a smart, easy and universal way to connect devices into your control network. Okay, so to make it a bit more understandable, I just copied the industrial pyramid, the automation pyramid. And you can see on the top the PLC level, and you can see on the bottom the sensor actuator level. And basically IO-Link is everything in between, it's covering everything in between. You can see the second level down here is the field bus level. And here you can see the most important IO-Link product, which is the IO-Link master. And to this master, you can then connect several sensors and sensor hubs. So you can use IO-Link sensors, you can use normal sensors. So basically, this is to symbolize an IO link is here in the middle, giving the interface between controller level and sensor, standard sensor level. So to have an IO link system, what is the components we actually need to have an actual IO link? First one, we need this IO link master that I just mentioned. We can also call it a gateway. So the master looks like this. We've got 8 ports to connect 8 sensor or hubs, and the master comes with a GSC file or EDS or XML file, depending on what PLC you actually use. Second of all, of course, we need a sensor. So an IO link device. For this example, we use a Balluff optical distance sensor. And every IO link device actually comes with an IO device description. Okay, so the description actually contains information about, okay, who's the manufacturer, what is the material number, and additional information about the device. And finally, to connect these two, we also need a cable, obviously. Okay, so in IO link, everything works with a standard, unshielded 3-wire cable. The maximum length is actually 20 meters, but very important is to know that we actually use a very, very easy standard cable. Okay, so what I mean, yeah, this looks still very easy and not too much different to your existing layout, maybe. So what exactly is the difference? What is IO link actually doing in the background? It's about the communication. So IO link issues a serial telegram to communicate to IO link devices. And in this way, the same cable can be used to integrate intelligent sensor together with any standard sensor. So, okay, to understand this a bit better, I've just copied this table here, created this table. So on the top, on the first line, you can see standard IOs, input outputs. As you know, standard input output is 24 volt, basically on or off, and it's basically a 1-bit data, which comes in a cyclical time pattern, and the transmission time is quite easy. Okay, so this standard signal is still included in IO link, it's also covered, but with IO link, as I mentioned, we have a serial telegram, so you can see here, the signal with a serial communication looks, for example, like this. And by doing this smart communication, we can transfer additional information, not only 0 and 1, but we can actually transmit process data of the input and output, as well as, this is the most important part, service data. So what do we consider as service data is, for example, the device parameters and diagnostic data. Okay, so there's additional information that the sensor feedbacks back to the controller using IO link. In total, the data can be up to 32 bytes. So it's a lot more, obviously, than a standard input-output. And therefore, also the transmission time actually increases. It can be, if you use the full data volume, it can be up to 32 milliseconds of transmission time. So yeah, here you can actually see the wiring. Pin 1 and pin 3 is used for the power, plus and minus, and pin 4 is typically used for standard input-output, as well as IO link communication. Okay, so on one pin, both communication protocols will be feedbacked to the PLC. One very good advantage of IO link, of an IO link master, is that we have the option, or basically the advantage is that the master comes with its own IP address and a web server is running on the master itself, which enables a connection to any kind of computer. So the interface is called a RESTful API, but in the end, you can connect the master to any computer, which then allows you also that the master can communicate with higher levels of any other systems. for example, the cloud. So on this picture, you can see the master being connected to our PLC. In this example, we use Siemens PLC and Trophy bus protocol. But actually, on the right, you can see we have different masters for any PLC bus protocol. For example, CC-Link, CC-Link IE field, DeviceNet, Ethernet IP, and EtherCAT. So yeah, on the right side, this is the connection to the PLC, whereas we could also connect the master straight away to a PC. So what would happen here is, this is basically the access. I put the picture here. This is the access to the web browser. So on your computer, you could configure each port for what information do you want to receive, input, output, or IO link. And then from here on, yeah, there's basically no limits on how you want to use the data. And for example, you could upload it to a cloud. You can visualize it to different dashboards. And we will give you one example later how it could look like. Okay, so yeah, coming to the next topic. How can IO Link, this technology, help to decrease the machine downtime? So one is, we get additional information. We get information about the condition of the sensor. Means we can predict the maintenance intervals and we can plan the downtime. So means we can, yeah, basically decrease unplanned downtime, but we can actually say, okay, this sensor or this machine has to be maintained next week because the parameters look like this. Also, IO Link enables a quick exchange of sensors. So I didn't mention it yet, but every connector is actually standardized to M12 and with this 4-pin or 3-wire cable, as I said. So it means the cable is always standardized, so you do not really need a hard wiring process. Everything is with the same connector type. Another advantage is you can store your parameter on your PLC, and once you connect the sensor, you can actually configure the sensor from your PLC. Means the parameter data will be sent to the sensor and straight away be functionable. And then I also mentioned before the device description. Means you can identify every device. Means you actually have the possibility of auto-scanning all the devices that are connected to our controller, and it will give you a nice list of all IO Link devices connected to your current system. And finally, by having an identification of each sensor, you can also not really confuse them because, yeah, it's basically unique descriptions for each sensor, so you can't mix them up with each other. So I put this picture here, which is actually very similar to the IO Link topology. It's really that easy. It's just plug and play, like an easy power plug. Everyone can start using a power plug, and that's almost the same as using an IO Link device. It's just plug it in, and it basically works. One topic that can also help to decrease your machine downtime is inventory management. Typically, it's done via RFID technology. So you can see here on the little picture that these workpiece carriers, they have a small, in black here, a small RFID tag. And basically all the carriers are tracked and traced amongst your production, so that you can collect information about which machine has been used for which process and so on. So it's a very, very big topic, RFID technology. But in today's topic, I do not want to focus on it, but I want to mention that RFID is also compatible with IO Link. So it means we have RFID read-write heads that can directly be connected to IO Link master. Okay, so now we come to the second topic of machine monitoring. One example that we have for giving additional information is a smart power supply. So it means the power supply gives typical 24 volt, but it actually also monitors its own process, its own data. So the information you get from the power supply through an IO-Link interface is you get how much voltage is currently used, how many amps are currently drawn from the system, and what is the resulting watt number out of these usage data. And finally, you can see here, I zoomed in a bit for the ones that don't have that sharp eyes. You can see 3 indicators here. So stress level, this is actually the current amps which are drawn, the load level, which is the current voltage consumption, and the lifetime. So lifetime is actually the perfect example of the power supply giving you an estimated time of when is the next time that you have to maintain the power supply. And also, obviously, power supply gives you information about all the sensors connected to your system. So this is one very good example of a power supply, usually a standard product, but with IO-Link, it gives you additional information about your system. Another example is a condition monitoring sensor that actually gives you vibration, temperature, and other values. So this is also the sensor we would like to focus on in our live demonstration in a minute. Usually, this kind of sensor is used for motors, pumps, and valves. You can see here it's usually big devices or big machines. Actually, in our office, we did not have any of these machines, so we used. So the only machine we were able to find was a coffee machine, which is also working very fine. So I'm happy to share our coffee machine findings in a minute. So just quickly on this sensor. Sensor looks like this. In this housing, there's actually multiple sensors installed. It's a vibration sensor, temperature sensor, ambient pressure, and humidity sensor, all included in this one housing, as well as a little microchip. So the sensor is able to pre-process the data, okay? So for onboard calculation of statistical parameters. It also can store information about the events, means like what thresholds you want to set to maybe cause an alarm, or to maybe for any kind of actions and alarms. What is the thresholds that you want to define? This is what you can store directly into the sensor, this information. So the whole sensor comes in a IP67 or IP69K housing. Of course, it has an IO-Link interface, as you can see here, the symbol on the right side. And it comes again with our standard M12 connector. So this is what we will show you now through our second webcam. We have a coffee machine on the left, and we mount our condition monitoring sensor on the machine. It's connected to our IO-Link master. So this is a small version of the IO-Link master. It has its own IP address. We connect to the web server. The data is actually visualized in Node-RED. Or basically, there's a data model behind, and the final result will look like this. It's an actual dashboard of giving you information about 3-axis vibration. So you have X, Y, and Z axis. And we also can see the temperature. Okay, so I'm gonna stop sharing my screen and hand over to Amar. And let's see if our coffee machine can perform well today.
So thank you, Fred. Actually, this live demo is supposed to be in SHRDC class, which they also got this one DC motor so that they can monitor this via vibration of the motor. So the idea is when they tighten the cables, the cable chain, and then it will be less vibration. But yeah, since we are in this COVID, and then our government announced there's gonna be an MCO, so we find our own solution. So let me just share our screen. That yeah, we are using coffee machine like Fred mentioned just now. Okay, so as you can see, this is our coffee machine, and like Fred mentioned just now, in order to use IO-Link product, first you need a gateway. So this is the gateway with 8 ports, and then the first ports here are configured as IO-Link. Okay, and then this is the vibration sensor that is connected on the first port. Okay, and as you can see now, it's connected to this metal base of this coffee machines. So in order to display this value, I'm using a Node-RED. So I'm making my laptop as my server, and then here is the flows that I'm using. So I get the data. Oh, sorry. So then let me just share. Let me share my whole screen. Okay. So this is the flow, Node-RED flow for this software. And as you can see, I'm using RESTful API. So here I'm using the IP address of the master hub itself. And then I expand it to show this X, Y, and Z. Okay. So this one actually the vibration acceleration that I'm monitoring for the coffee machines. And as you can see, so please take note, here is the value that I'm showing right now. And then here is the graph plotted between time and then the angle. So before let me show you this when I try. So as you can see, now I'm getting all direction, okay, for X, Y, and Z. And if you notice for Z direction, it stopped a little bit and then it started to increase back again, the vibration. And we got a higher peak also at Y direction. Okay, so actually this kind of data we can also view in ISO standards. So if I'm open up. Okay, so by following the standards, so let me explain a little bit here. Here it falls into 2 categories based on ISO 10816-3. If you mount your pumps or medium-sized machine motors or valve on a rigid or flexible places, then you can monitor this velocity for each value. Example, if I'm mounting my pumps on a rigid ground, that means if I'm having 1.4 or 2.3, I'm still at 1.4, I'm still in good condition. But when I'm start rising up to 4.5, there is a short-term operation allowable. Okay, and then if I goes more than that, then the vibration will cause damage to the motor or machines. So this is like a guideline that we can follow based on the ISO standards. And other than that, these sensors as well, I'm plot the temperature as well for the graph. So as you can see now, if I'm moving near to the cups of this coffee, so the temperature keep increasing and increasing. So yeah, so you can monitor this tool, all of these 4 data. So as you can see, it's kept increasing 3.33.6.8. Yeah. So I think back to Fred.
Okay, thanks Amar for the very quick demonstration. I'm glad to find that our coffee machine is still healthy. It's on a healthy level. It was below 1.4. I believe. So, okay, we can still use it. Okay, so quickly back to the demonstration, to the PowerPoint. So, okay, yeah, this is what we just showed. The sensor was actually mounted here on this metal grill, and when the temperature went up, Amar actually threw the sensor inside of the cup, so it increased. And the sensor is IP69K, so yeah, no problem about any water or coffee close by, no problem. Okay, so the last quick topic is machine flexibility. So how does IO-Link support your machine being more flexible? First of all, it's a simplified architecture in general, the IO-Link. Again, you see the master, and it's connected to a different kind of sensors and hubs, always using the same standard 4-wire cable, and it's also using a digital signal. Means you don't need a shielded cable. You will not have interference, excuse me, with any parameters close by, but it's a stable connection. All the sensors, including the master hub itself and the hubs, is IP67, means you can place them outside of the machine cabinet. So it gives you much more flexibility of designing your machine. You don't have to wire everything back to the cabinet, but you can just place it anywhere where it's convenient for you and where you can save some wiring and cable effort. I already mentioned that we have masters for all kind of bus protocols. So here I can connect to all PLCs, as well as you can connect to any kind of computer using web browser. You have an easy format change, because the PLC will auto-teach sensor parameters when you have a different product. It's quite typical in the nowadays production that let's say you want to manufacture 2 types of products with a different size on the same machine. So it means you have to teach your machine, okay, now this is the end size of the product, and then you put a bigger product on the production, and of course all your parameters will change. So you can auto teach that to the sensor using the IO-Link from your PLC. A very good advantage is also that you can connect digital as well as analog sensors. So both signals can be transferred using IO-Link communication. And finally, also very important is IO-Link is basically a world standard. There is a DIN international standard norm behind. And on the picture here, you can see all the brands which is using IO-Link. And all the devices is compatible to each other. Means you can use a Balluff sensor and connect it to any other brand's master or the other way around. Means you're not really focused, you're not committed to one brand only. No, but you have the whole market open for yourself. Okay, so yeah, these were a few short insights into IO-Link technology. And we are very, very confident to say that it can increase your productivity. We have experience with IO-Link since more than 15 years in several countries and a lot of happy customers. So please contact us in case of any questions. My contact details is here, and we are happy to have given you a short insight into IO-Link and Balluff as a company.